Now starting with, oh crap. Everybody's here.
Everybody's here.
Oh crap. Wait, huh? Okay, Gatika and Nadia. How are you people doing? Just a second. Okay. Hello, Abdul Mois. How are you, Abdul Mois? Abdul Mois, you said you will be uh, regular. You told me this last time. Then what happened?
I just missed one class.
That's not good. You're not supposed to miss any class. Okay?
Right.
Because I know it is different when you're watching recordings. You can't ask questions. You don't have, that ability. And recordings are generally very boring as well. So please, do join.
That's true.
Yes, that's why I'm saying do not miss the classes. That's not good. Okay. Now, so today we did basically the production of suitable radioisotopes. If you guys have any questions about it, please do let me know. Otherwise, I'm gonna going forward, and we're gonna do detection of gamma ray photons. Okay. Now, so what we do is that we have series of ring detectors in a donut type shaped bed. So series of ring detectors in donut type shaped bed are placed now. Series of images of different slices are taken similar to CT scan. Basically, we want to construct a 3D model, that's why. Okay. Now, detectors of gamma ray photons consists of two parts. Number one, a crystal that scintillates. Scintillate, it basically sparks a bit when the gamma photon interacts. And the next thing is a photo multiplier. Cool. Now, when a gamma ray photon is incident on the crystal, an electron is excited into a very high energy state that we have learned in quantum physics, basically. Okay. As the electron travels through the crystal, it loses energy and excites more electrons. So it's basically, losing energy to the electrons nearby. These electrons decay back to their original states, releasing visible light photons. Now, the photons produced by the skin scintillators are then converted into electrical signals by the photo multiplier tube. That's the function of that. Okay. The computer then plots back where the photon pair was originally produced. Like that. Okay. I'm going to show that, so please don't laugh at me, my drawing. So, hold on. Till you can complete writing this, please. I'm going to show you how the ring detectors are and stuff like that. Oh. So we have detection done, and now we have moved to reconstruction of image. That's the last thing. And then we're going to solve some questions from PET. Yay. So basically it looks like this. So there's ring photons. This is the person's head, and the other thing is the shoulders, okay? Think like that. Now what I want to tell you is, suppose that this is the point where the red one, this is the point of electron positron annihilation that we did first, and we learned that two photons are going to be released 180 degrees to each other. Now naturally this line that they will release into is called the line of response. And now you need to understand this, that of course if it's basically pointed at this point, so if I say this is the photon, this is the detector A and this is B, suppose. So because this point is closer to A, so basically the photon is going to reach detector A in a faster than B, because it needs to travel less distance. Do you guys understand this? So the difference of the time between the two detectors where they basically arrive basically helps the computer to know exactly which point is this photon coming. So if there are a lot of photons coming from a single point or area, then of course that is where the cancerous or mutated cells are. So this is just telling you how it's done, and I'm gonna write it now. So we're gonna say photons travel in a straight line and in opposite directions, which are basically 180 degree. And strike the detectors, okay? Using the time lapse between the two photons, because they arrive at different time, right? Arriving at the detectors, the position on the line of response can be established the number of photons arriving from a particular point determines the concentration of
ग्रीन टी बना दो। अच्छा, कप खाली है?
ये कप जी जी
ले लो।
जी जी
अच्छा,
ग्रीन टी आप मुझे बना दें बस.
ठीक है।
Tracer at that point, like this, okay? So that's why we can detect where the problem is, because of course the point where there will be more concentration, it means more photons are being released, and that's all. Is that clear, everybody? Okay. Do you guys feel good about it now? Okay. That was kind of uncalled for, but anyway, let's now go to the next thing. Okay. Please write it down, then I'm going to show you some of the questions because this is fairly new, right? So last year, like this year, 2022, May, June, it was tested for the very first time. So whatever we have, we can use that to analyze what we're doing. Just a second, give me just a second. Let me just post some of the papers and then we'll try to do this. Wait, we have okay, share with what is this? This is not fair. Ek second, huh? Just a second. Okay, I have to open it here. Now this paper is from May and June 2022. Okay, I don't know if there is a question about it or not, but anyway, we can still try to Okay, let's see if we have a positron question in this. No, this is not the question. X-ray question. Okay, sadly, there was no question in this one for PET. Very good. Now let's go to the next paper. Let's see if that has. Why? Even this one, there's no question. Wait a second. Let me look at it once more.
So there is one in the specimen paper.
Yeah, but I don't want to. I've done it 10,000 times. This very easy question. I want to do something difficult. It doesn't have it here as well. Okay, let's try the other one. 4-3 now. I wonder if the October-November papers have been released. I'll try to look at the school support hub. Let's see if they have released it there. I had the credentials for it. Never used it though. Wait. This is, it looks very similar to the first one. Yep, it's 100% same. They just gave the same paper on 4.3 and 4.1. Okay, I failed. Never mind. So we have to look up with the specimen one. Let me just go there. I'll copy it here. Wait a second, please. That's not fair at all. So 9702 2023
So
specimen.
how about March 22?
March, the syllabus was not effective by till then. It was only
But it
testing.
does have PAT.
It did.
Yeah.
Are you sure? Okay.
Okay.
Sorry. It means. Wait a second. I'll try to find that then. Wait a second, please. Why do they? So you're saying February, March 2022 had that question.
Yep.
Okay. Okay, I'm opening that. So they didn't even try to test it in May, June, the biggest exam. I'm very sad about it for some reason. Okay, airdropping. Wait a second. Yes, please. Okay, so here we have Gatika, are you 100% sure about it?
Yes, sir.
Okay. What is this? This is the boy. Oh, Gatika, you are so right. Very good, Gatika. Okay, Gatika has saved us a lot of time. Now let's look at this question now. So this is the only question up to now. So first of all, the question says, a PET scanning uses a tracer. Explain what is meant by tracer. Basically, I gave you the definition for 2 marks and here it is 1. So even if it's that, you still need to do it. So tracer is a radio active substance introduced into a body. I think that would be enough, but it would be nicer if you write it that is absorbed, because sometimes it might be 2 marks, right? Absorbed by tissues being studied. So that's the standard definition that they will ask you again and again. Now, PET scanning involves annihilation. What is meant by annihilation? So, annihilation basically means when a particle like electron interacts with antiparticle like positron, their masses are converted to energy, right? So we already know E is equal to mc squared, like that. Anyway, now state the names of particles involved in, oh, we know, positron and electron. You guys know this already. Now calculate total energy released in annihilation. So that's pretty easy. For that, you guys need to remember mass of electron is 9.11 times 10 raised to minus 31. If you forget, you go back and check the...
बाहर ना वो इंद्रयास आया, आपके पापा घर में नहीं है।
इंद्रयास कौन है?
वो गाड़ियों के लिए आया आदमी, इंद्रयास पता नहीं।
हाँ हाँ, उसको कैसे साफ करें?
दे दूं चाबी?
And the yeah, anyway, and the speed of light, you should remember this, is, if you don't remember, you can go back. Now, when I say their masses are converted to energy, so you should remember it's basically connected to E is equal to mc square. So total energy will be equal to mass of electron plus mass of positron, which is also an electron, technically, right? Only opposite charge. So you're going to say 9.11 times 10 raised to power 31 minus times plus 9.11 times 10 raised to minus 31. So that's the total mass multiplied by 3.0 times 10 raised to 8 whole square. Can you please help me with this?
(1.64 into 10 raised to minus 13).
Yeah, so that should be basically your answer. Then it says calculate the wavelength of gamma photon released, and the wavelength can only be found out by E is equal to hc upon lambda. We have the energy, so lambda will be equal to hc upon now the thing is that it's not about, basically these are two, when they combine, it says each gamma photon is released, which basically means that technically this whole energy is for two of them, right? So we are going to do this whole thing divided by 2. If we do that, then basically it is going to be lambda equals to 2 times hc over E. Because basically it's like 2 photons are released, it just says each, that's why we're doing this. Anyway, so 2 times 6.63 times 10 raised to minus 34 is the Planck's constant. 3.0 times 10 raised to 8 divided by energy is the same as one that we found out earlier, and the answer is yes, please. Go on, hurry up. You guys so slow.
Sir, 2.43 into 10 raised to minus 12.
2.43 times 10 raised to power minus 12 meters.
Yep.
Okay, fine. All right, any questions, please let me know. Anything you would like to know? Aman, Nadia, Saman, Abdul Moiz. Okay, very good. Now, the next thing we're going to do is basically explain how gamma photons are used to produce the image. Now, this is what you need to write. The production of like gamma photon, from the perspective or notes, when you go there, I just want to point out so you guys know exactly what we're doing. So in the notes, I've written it right here, detection of gamma photon, and yeah, this one, reconstruction of image. That's what they want you to write, okay? We'll be talking about how the gamma photon is used to produce an image. So we're reconstructing it. So we're going to say that at the point of annihilation, two gamma ray photons are released that travel 180 to each other. You can also write opposite if you want to. It's fine. So that's 1 mark. These are detected by series of ring detectors, right? That would be one more mark. They arrive at the detectors at different times due to their position. All right, now what you're going to do is you're going to write the computer basically determines the location of annihilation or production. You can write gamma rays gamma due to the time lapse, or you can write difference in time. Okay, just make it simple, it's okay. And then the concentration of gamma rays received can help us determine the help us reconstruct. Hello? Yes. Uh-huh. Mm-hmm. Acha. Chemistry, your boy? Hmm. नहीं उसको नहीं देना, उसको नहीं देना, वो मैं तुम्हें कॉल करता हूँ. I'll call you back my friend. तुमने पॉइंट्स बता दिए. Okay, I'll call you back. Okay. अच्छा, the concentration of gamma rays, the concentration of, not the gamma rays, it's basically concentration of tracer is determined by number of gamma ray photons arriving at that point. Is that clear, everybody? Arriving from that point. So you can write these. This is the standard, the same thing that we wrote about, reconstruction. In fact, we don't really know what they're going to ask you because we have only one paper and then one specimen up till now. So it's better that you guys are prepared. And that's why I've made you write so many things, unless, we know that what examiner wants and we can redefine it like other medical physics things. All right. Any questions, please let me know. Abdul Mois and Suman and Gatika, Aman, Nadia, everybody is clear about it? Okay. I guess I'm gonna see.
So can you explain the detection part, please?
Where?
In the notes.
Notes. Okay. Why not? Okay.